Welcome you guys. Welcome to Unacademy. This is your BWP sir. Right. As we are continuing the DPP discussion of Boolean algebra, so let's continue our discussions. And before this, we have a great announcement from Unacademy. In GATE 2024, the Unacademy students are did the extraordinary performance. You can have a look at now. All the top rankers from the Unacademy only. Now it's time for you can start your serious preparation with an academy to achieve your dream goals. इसलिए हमने आपके लिए बहुत बढ़िया से बढ़िया ऑफर लेकर आया. With this, you will get flat 50% on डिस्काउंट आपको मिलने का चांस है. एंड इसके साथ और एक 1 मंथ का एडिशनल सब्सक्रिप्शन भी मिलेगा. 1 मंथ का एक्सटेंशन होगा. सो यू कैन यूज द कोड ऑफ my personal activation code I am providing you fellows, that is be ready to avail this great offer. And this offer is valid only up to 30th only. Utilize this opportunity before it going to expire. And this Diwali के बढ़िया से बढ़िया offer आपके लिए है. So utilize this opportunity before going to expire. For that you can use the activation code of what? Be ready. And you can join the live classes starting from 25th onwards. 25th. So I'm starting the 25th network course हमने शुरू किया. So you can do follow these courses. And 26 के लिए भी EMT शुरू होने वाला. So, and these are the plus features. With the plus, you can get the raise a hand option, class polls, handouts, daily practice problems, communities, and learn from your comfortable home and study bit. PDF फॉर्म में अभी आपको मिलेगा. Unlimited access and the India's top educators team. And these are the plus features and iconic feature. Plus में आपको बेस्ट एडुकेटर्स का क्लासेस देखने का चांसेस है. इंटरैक्टिव लाइव सेशन, स्ट्रक्चर्ड कोर्सेस एंड पीडीएफ, लाइव टेस्ट एंड क्विजेस एंड डिजिटल बुक एक्सेस. एंड आइकॉनिक के लिए सो इन एडिशन टू द ऑल द प्लस फीचर के साथ एडिशनली आपको 1-to-1 मेंटरशिप एंड फिजिकल बुक्स भी मिलेगा. And so you can get 90% of scholarship based upon your performance. Now these are the list of books for electrical के लिए मिलने वाला. You can have a look at now here. And these are the books for EC के लिए. ठीक है. चलो आज का सेशन हम शुरू करेगा. Right. And previous, this is the 5th lecture. So previously we have completed all these problems. We have completed. The student who have missed the previous classes, you can do follow the previous in this same playlist. आपको मिलेगा. So I think शायद हमने 105 तक हमने problems complete किया. ये सारा problems in detail मैंने हम अच्छा से discuss किया एक problems. And so let's continue the remaining problems. अभी हम बाकी प्रॉब्लम्स भी डिस्कस करने वाला. ईच एंड एवरी प्रॉब्लम वेरी डिटेल्ड मैनर, कंप्लीट सॉल्यूशंस. सो हियर एंड दिस द डीपीपी प्रॉब्लम्स. इट विल कंटेन्स द previous year questions of ECE, electrical instrumentation and computer science also, and GATE as well as ESC also. All the PYQs are included in our DPP what we are going to discuss. By solving these many problems, you cannot miss any problem. You will be perfect to be able to solve any type of problems. You can able to solve it. So yeah, 110 problems हमने complete किया. You can see. Next, take the next problem. 111. The logic expression is equivalent to what? The logic equation which is equivalent to what they are saying here. So you can tell me now here this expression y which is given as what you can see, a b c bar plus a b bar c plus a b bar c bar. Check this thing here. Now let's try to minimize this expression. Now what I can do here, if you try to combine, so then this is 1 with this thing, 1 and 3 if we combine. So here I'm taking this as a c bar common. Then I can say this as what? Tell me now, b plus b bar plus what? Tell me now here, a b bar c. So this is which is given as what I can say now here A C bar plus what tell me now here A B bar C, and this is which are taking it come A common, then it is C bar plus what tell me now here B bar C. Abhi either we can do the mingle property, try karo. We can apply mingle property, and if we apply mingle property, now you tell me now what I'll get. So this is A into what tell me now here C bar plus B bar hoga na. So कौन सा option tell me? Option D. Next, let's start be defined as like this. Now they asking. So here they given the condition as x star y, which is given as something they given as x bar plus y they given. Now so that is z, which is given as x star y, and that means this is nothing but what? X bar plus y hoga. Now I need what tell me now here z star x. It should be given as what tell me now here z bar plus x. So we have the z is what tell me x bar plus y. तो z बार क्या होगा यू टेल मी नाउ, इसका कॉम्प्लीमेंट x बार प्लस y का होल बार, ये क्या बनेगा इधर x y बार. So replace now here this is x, so x y bar plus x. If I take the x common, then it will be a 1 plus y bar now. 1 plus anything is 1, so that is x only. So option B. Next, and see this thing what they given now here f of a comma b, they given as what you tell me now here a bar plus b. I need to get what tell me now here. So first we'll find the inside bracket part. This part we are finding f of x plus y z. Here in place of x what we have tell me a is the, in place of a we have this thing. This part mean this thing. This mean this thing now here. So when a comma b means a bar plus b. When it is this, which we can say this as x plus y whole bar plus z. Check this thing. And so this means what I can say now here x bar y bar plus z. Now from this what I can say now here this part. Now so this is what they given, x or y given. This is y given. Now we took it as z we have taken. So this is y given. Okay. C is given, y given. Okay, so that means this value it should be given as mingle property x bar plus y banega. Right now this is x bar plus y comma z. Abhi boli idhar. So this value, now this is x bar plus y ka whole bar plus z, and this is what tell me now x y bar plus z. So कौन सा option C? The Boolean function which is equivalent to what? F is given as x bar y bar plus xy plus x bar y. So then F will becomes, if I combine these two, okay. So we'll combine this thing. I'm combining these two, I'm combining. So if I taken this as X bar common, then it is Y bar plus Y banega, right? And if I combine these two, let us say Y common, then it will be X plus X bar banega. So then F is equal to what? Tell me now here, X bar plus Y. So what's the option? Next. F is equal to F1 into F2 plus F3 in canonical sum of product. Now they are asking what will be the F3. Okay. So they given the min terms of F1. F1 min terms are given as what you can see. That is 4, 5, 6, 7, 8. Next, F2 min terms are what? F2 min terms are 1, 6, 15. That means 4 variable wala. So you tell me now what are the min terms of F1 into F2? That is the intersection common min terms will come. You tell me which are common here. So is दोनों में common कौन you see this thing here? Yes, 6 is common in these two. So only 6 will come. Right. Next, F3 not given. Now what they given here? Other one is F given, the resultant. And see the function what they given here. That is F is given as what? Tell me now here. F1 into F2 plus F3. Now they asking the F3 min terms. And F में क्या होना पड़ेगा इधर? So F में क्या we should have, you tell me now F में what we should require, you tell me now here. Min terms are 1, 6, 8, 15. And this F1 and F2 में हमको केवल 6 मिला. And what this must contain, you tell me now here minimally 1, 8, 15 must be present. That is what I can say now here. तभी ये आएगा ना. So what are the F3 min terms are, you tell me? 1, 8, 15. Even 6 भी होगा, but minimum this must be contained. Right. So finally we have finished the Boolean algebra. We have completed. Now we enter into the logic gates. Let's see one by one logic gates. Yes. In the logic circuit shown in the figure Y, what they given, this Y is given by. So what is this Y you can see now here? And how many levels are there? 2 levels are there. Level 1 and level 2. So we have seen 2 level and R logic. Level and R logic, and which is identically equal to 2 level and NAND logic. Remember? Two level and R is equal to 2 level NAND and NAND logic. Here we have 2 level NAND logic, that is nothing but 2 level and R logic only na. Level 1 में AND gate treat करो, level 2 में R gate treat करो. So means what I can say, tell me now here, AB plus what I can say, CD. Yeah. Next, the expression. So you can see now this is a Barfi. हमारा Barfi series में this is a Barfi ना here. Series. Barfi series में Barfi ना कौन सा Barfi? You can see now here NAND Barfi. So that is NAND Barfi बोले तो this is what tell me now here XOR gate. NAND Barfi है तो this is XOR gate ना here. So what's the option you tell me now? A. Next one. For a 3-input logic circuit shown below, the output Z is. Now you can tell me now here, this is connection is there now here. What we have tell me now? P bar whole bar. And here this is what tell me now? Q. Finally हमको Z क्या मिलेगा? You tell me. P Q bar whole bar into Q R whole bar again whole bar. Yeah, you tell me what I'll get. That is P Q bar plus Q R. P Q bar, yes, whole bar, and this is what tell me now? Q R whole bar. Okay. One more thing, into Q. So that means that is plus Q bar hoga. So that means Z, it will come it as what we can say. If we combine these two here, so हमको Q bar common ले लिया तो Q bar plus what tell me now here? Q plus R. अभी mingle property किया तो so Z will becomes what we can say now here? Q bar plus R बनेगा. So option C. Next one. A and B are the logical inputs and X is a logical output. X is output they are asking to find. Now you can see now here इधर हमको क्या मिलेगा? This is A bar. इधर हमको B bar मिलेगा. And here this is what element now here? AB. And here this is what we can say now here? A bar into B bar. So that X is what you tell me? That is A bar into B bar plus what tell me now here? AB. So this is nothing but which gate is a XNOR gate, and this is a XNOR gate. So option C. Yeah, now you tell me now what is output. So this is X, this is Y bar. So here will come to be X, Y bar will come. And here it is what element of here? X bar into Y will come. Now you can see this thing here finally. F. It should be given as X, Y bar plus X bar Y. So option you tell me, huh? Yeah. XR. Now this output. Yeah, tell me now here. This is X, XR, Y. Now this is X naught now. Now this is the AND gate. And here this input, sorry. And here these inputs are defined now. This input is what here? This is X, XR, Y. So this value will come to be a what element of here? X, XR, Y. And this is X naught with Z. And so this is AND gate finally. Is an AND gate. So this here it will come to be a what tell me? X, XR, Y. Okay, X, XR, Y into, yes, into what tell me now here? X, XR, Y C is XNOR with Z. This F, which we can write it as X XOR Y, and this is into, we can apply this as XNOR gate property. So this is A. If I say, you tell me now what is this thing here, A XNOR Z, which will be given as, what, tell me now here, A bar Z bar plus, what, tell me now here, A into Z. Now A bar means what, tell me here, A means this is, so here X XOR Y, this is A bar into B bar, so this is A bar into B bar plus, what, tell me, A into B. A means X XOR Y, A into B. All of you this thing. From this, what I can say now, if we multiply this thing here, so this is will become, first term will become 0. Okay. Next here, this is X XOR Y in Z. So this is given as, what, tell me now here, X bar Y plus X into Y bar whole into Z. So what's the option, tell me? Okay. In the circuit shown in the figure, if C equal to 0, the expression they ask him to find, they given the C value 0, means this is given as a 0. If this is 0, this is 1, here this is 1. Here is, what, tell me now here, A plus B bar, C value anywhere 0, so this no effect. Here this output is, what, tell me now here, A plus B whole bar, and this is, what you can see now, this is AB. Here what will come here, A bar into B bar plus, what, tell me now here, AB, and finally Y will come to be a, what, tell me. So what is this thing? This is nothing but XNOR, na? This is nothing but XNOR. So this is 1 into A XNOR B whole bar. So then this is nothing but, what, tell me now here, A XNOR B. So then will be given as, what I can say now here, A B bar plus, what, tell me now here, A bar B. The output Y in the circuit below is always 1 when. So first we'll find the logic expressions. Here what I'll get now here, this is P and this is Q. PQ bar. Here this is, what, tell me now here, Q R bar. And so this is PQ bar into, what, tell me now here, QR bar whole bar. Again bar, so then bar will get cancelled. So this is, what, tell me now, PQ bar into, what, tell me now here, QR bar. Here. Now what about this thing here? This is PR bar. Now finally, what I will get this Y. It should be given as, what, tell me now here, PQ bar into QR bar into PR bar. So then which will come to be, what, tell me now here, PQ plus, what, tell me now, QR plus, what, tell me now, PR. So if you observe carefully, this is called as a majority gate. Remember, this is called as, what, tell me now, majority logic expressions. And this means when this output is 1, if 2 or more number of inputs are 1, then output is 1. In this case, what happens, you tell me now? 2 inputs. Is 1. That means what are me 2 or more number of inputs are. Next one. You can see now here, and this is x, this is x bar. So what is this thing here? X r with x bar, which will be equal to 1. XOR gate, if the different input are given, output will become 1. XOR gate is called as a inequality detector. Next, for the output F to be a 1 in the circuit shown, the input combinations are, they are saying that output must be a 1. This will be 1 when the output of x NOR is 1 for in case of a even number of ones. So here you can see now verification of options. The first option may here we have seen this thing 1 1 and this is 0. You see this thing 1 1. So what will be the output? You tell me now. X OR gate. XOR gate 0, XNOR gate is 1 and this is 0. So what should be now here? Output will be a 0 now here. In this case, output is how much? You tell me now. 0. Next, in this case you can verify. So this is A value 1, B value 0, C value 0. In this case, this is 1, this is 0, this is 0. So still be 1, still be 0 only now. Next, in this case, you tell me now. A value 0, B value 1, C value 0. So this value is 1, this value 0, and this value 0. Still in this case also F is equal to what? Tell me now. 0. Now you tell me now here, option D. Now this A value 0, B value 0, C value 1. So then this value 0. This is 1, this is 1. Yes, even number of ones now. So this output is 1. Okay, when the XNOR gate output is 1, you tell me now. XNOR gate for even number of ones. Even number of ones, output equal to 1. Next one. Oh, the logic expressions. Yeah, you tell me now. This is X bar. Okay. And this is Y bar. And here this is X bar into Y whole bar. So this means X plus Y bar. Here this is X Y bar whole bar. And this is what I can say now here. X bar plus Y. So from this Z, it should be given as what I can say. Tell me now here. X plus Y bar into what? Tell me now here. X bar plus Y. So then will come whole bar is also there now. Now you can see now here. We can apply the T2 we can apply, then it will come to be a what element of here xy plus what element of here x bar y bar whole bar z, which could be given as what element of here x naught y ka whole bar, that is nothing but what element of here x r y. Option A. Next, M1. Yeah, here what I will get to tell me now here PQ bar. Here P plus Q. So then here what I can say now here, this is P bar plus Q bar into what element now here P plus Q banega. Okay, so then this is if we apply T2 now, so then it will become P bar Q plus what element of PQ bar. So that is XOR gate. That is P XOR with Q. And here this is R. So from this what I can say finally M1 equal to, that is P XOR Q and XOR with what element of R. So comes the option here, option B. For the circuit shown in the figure, the Boolean expression is, here we have P, this is Q, and this is PQ bar, again bar, so that's why you will get complement, sorry, this is P bar, Q bar, this is what element of P bar, Q bar, whole bar. So, and then this is what will come here, P bar into Q bar. Here also same thing will come here, R bar into S bar will come. Here finally Y will becomes what you tell me, P bar, Q bar into R bar into S bar ka whole bar. Then, so that is P plus Q plus R plus S. So comes the option B. Next, tell me now this thing. Yes, here what they given now B plus C. Here they given us BC. Here A. So this is what element of A into B plus C. Here this bubble is A bar. So that is what I will get now A bar BC. Now, so that is X, it should come to be a what element now? So this is A into B plus C plus what element now here? A bar BC. So that is X will come to be a what element now here? AB plus AC plus what element now here? A bar BC. So then X will come to be a AB, we'll try to simplify. Yes, so if I take the B common, then it is A plus A bar C plus AC, isn't it? Then it will come to be a what element of here? B into, so this is A plus C plus what element of here? AC. Then it will be a AB plus BC plus AC. So option C. The output of the expression is AB. BC. ABC. Right. And here what will come here? AB XOR with BC. will come to be a what? Tell me. So this is ABC XR with what? Tell me now. AB XR with what? BC. So that is Y, which could be given as AB we have taken common. That means C XR with 1. Okay. And XR with BC. So that Y, it should be given as AB into this is C bar now, isn't it? So this is Y. So if I take the B common, then it will seems to be a C XR with that is AC bar. We have seen this property if you have remembered. In this case, this XR will behave like it has what have we simply R gate जैसा behave करेगा in this situation. That is A XR with what tell me now here? A bar B. In this situation, this is nothing but A plus A bar B. So in this case, it will behave like this. That is plus into AC bar. Now we can apply the mingle property. So then, so this is E into what tell me now here? C plus A. So कौन सा option here? C. The digital circuit shown here is yes, this is the NAND gate. So that is X Y bar. Here this is Y bar. Z bar. Whole bar. Y bar. Z bar. Whole bar. Then finally F will come to be a what? Next Y bar. Y bar. Z bar. Whole bar. Again whole bar. Simplify this. XY plus what tell me now here? Y bar, Z bar. Here this is small, yeah, and this is what tell me now? Y bar, Z whole bar. For Z ko no bar na, isn't it? So, so will come to be a what tell me now here? So this is XY bar, Y bar, Z. Is XY plus Y bar Z. So option B. Next one. In a circuit shown, the output Y required to get. I need this output of Y this much. For this, what is a gates they asking to find? Due to they asking to find. Right. So we need the expression Y is what tell me now here? AB plus C bar D bar we need. Here this is what tell me now C plus D whole bar. This is nothing but C bar into D bar. Okay. Means for addition to be happen, this must be an R gate. And here this is what element of A bar and this is a B bar. We should put AND operation. So AND operation means this must be a NOR gate hona padega. This must be a NOR gate. So what I can say now, G1 is which gate you tell me now here? NOR gate. And G2 is what tell me now? R gate. So answer option? Option A. The circuit shown in the figure realizes Yeah, tell me now here, this is A plus B whole bar. And this is what, tell me now here, A plus B bar plus C whole bar. So it will come to be a what, tell me? So A plus B into C bar. Here this is what, tell me now, D plus E bar. And again bar, so this is D plus E will come. And so what is this Y value, tell me? B, which is equal to this bar will get cancelled. Y is equal to what, tell me? A plus B into C bar, okay, plus D plus E whole bar. Yeah, tell me now this thing, what I'll get. A plus B, De Morgan's law, into C bar whole bar into D plus E whole bar. So that Y, it should be given as what I'll get you, tell me now here. A plus B bar plus C into what, tell me now, De Morgan star D bar into E bar. So option, tell me now. So the expression of the shaded part, if I call this is 1 and this is 2. This is 1 and this is 2. Tell me now 1. It should be given as here A, B, but no C. Second one, here we have no A, B, C का common. क्या? Yes, option C में है ना? Right. Now, the number of Boolean function which can be generated with the 4 variables, number of Boolean variables. So that is number of Boolean functions. And which is given as 2 power n. N is given what will be 4, 2 power 4. So 2 to 4, 4, 8, 16. That is 2 power 16. So how much this value? This is 2 power 6 into 2 power 10. So this value 2 power 6 means what will be now here? So this so 32 into 64, 64 into what, tell me? 1024. By how much will come? 536. Next, the minimized Boolean expressions. Now, if I call this is Y, so this should be given as. So look at now here BC parallel. So this part is nothing but what will be now here A into B plus C bar. And here this is what will be now A bar into B. And this is A plus B bar into C. So you tell me now Y expression what will come? A into B plus C bar plus what, tell me now here? A bar into B plus what, tell me now here? A plus B bar into C. So this Y, it should be given as AB plus AC bar, and that is A bar B plus AC plus B bar C. So then simplify it now. If I combine these two, so what will come here? B will come. If I combine these two, then A will come. Plus what will be now here? B bar C. Now if I apply the Manzil property for these two, then that will come to be A plus, B plus C will come. And is B. Next, the minimum number of switching functions for the three variables. Switching functions means Boolean functions only. So that is number of switching functions. Switching functions is nothing but Boolean functions only. So how many number of Boolean functions are possible? That is 2 power n. So this is 2 power 3. So this 2 power 8. And this is how much here? 6. Or 8 now. So it is 256. Right, the expression. So how these two are parallel and this also parallel and whole thing parallel. So what it is now expression, you tell me now why if I say. So this is A into F plus B plus C, and these two are into D plus E. So the option is A. Next one, shaded part. And you can do the shaded part if I say this is 1, this is 2, and this is 3. So tell me the expression here. 1, make I A is there, B is there, no C. Okay. 2 make I A is there, no B and C. And 3 may what we have? A, no A, and B and C. So konsa option you can see? Option B. Next. In a digital system, there are 3 inputs A, B, C. The output should be 1 when at least 2 inputs are high. That is nothing but what will be a majority gate. So both these two will be correct now here. So here that is called as what will be a majority logic gate. Majority logic function. For that majority logic function, min terms of this majority logic gate is what? 3, 5, 6, 7. I ask to remember this thing. 3, 5, 6, 7. Next one. A bulb in staircase has 2 switches. One switch is at the ground floor, other at the first floor. The bulb can be turned on or also can be turned off by any other switches, irrespective of the state of the other switch. The logic of switching function. Right, so we can switch on this thing here by using the 2 switches. This is called as a staircase switch. Remember, we used to call this as staircase switch. What the working principle of staircase switch is? The staircase switch will work based upon XOR gate. Based upon XOR gate, staircase switch will function. And match the following. So here, this NOR gate, as we know here, NOR is equal to what tell me now here? Bubble to AND. Is equal to bubble to AND. So means what tell me now? This is 4. Peak of 4 hoga. NAND. Or what about this NAND you tell me? NAND is nothing but what tell me now? Bubble to R. and is nothing but what we can say now, bubble to R gate. So for this, bubble to R is 2 and XR. So from this XR, from this we can elevate the option 4 2 here. Next R को क्या होगा? You tell with 3 or 1 R को. So this is what tell me now here. One time bubble, yes, 3. So this is 1. So the option is what tell me now here? D. Check karo everybody. Got it, all of you? Verified. Done. Yes. Verify करो जल्दी. Right. Fine. So here, that's for these sessions. With this, we have finished up to 27 problems. We have finished now, and we'll see the remaining problems in the next class. Okay then. Okay then. See you. Bye.